Hi everyone, this is the GDG C# coding tutorial. You are here because you're not very aware of how to program and you would like to learn, and I kind of know how to program, so yay. Alright, let's get started then. Right, actually, before I get to this, I just kind of want to let everyone know, I don't want to be like me just telling you guys everything and it being super formal. If you have a question, even if you think it's a dumb question, there's no such thing as dumb questions. Feel free to just cut out over me and I'll try my very best to kind of explain it and walk you through it. So yeah, it's not formal here, it's super informal and chill. Right, so we're here because we want to learn how to code, and we want to learn to code in C#, which is a pretty popular programming language. It's what the Unity game engine uses. Now, the first thing we want to do is we need to actually get something to for us to write our code in and then for us to execute it. So if you guys have the slides up on Discord, you would see that there's a few different options on what we can use. Now, personally, I would say the best option is under the online C# compilers. Setting up a coding environment can be very tricky, difficult, super annoying, essentially, unless it's like Python, which is like super easy. So this would be the easiest way for us to actually write our code and to execute it. So if you go to .netfiddle.net, yep, that's the right URL, we will use that, or I'll be using that to do it. There also is a few different options if you do want to use something else. Like you have Replit, which is also like an online thing that you can use, but you need to make an account for that, and it's a lot slower. And you can also use Visual Studio Code, which is like a text editor, but there's a few steps involved to using that, and there's a few articles if you really do want to do it, but right now probably wouldn't be the best time. So honestly, I urge everyone to just go on .netfiddle.net. Easiest thing. And yeah, just go on Chrome and you can just use it based off that. So if I go on this, open a new link in a new tab, you'll see this pop up. Can everyone see that? Yes, they can. Does everybody have this or something similar up? Say I. Okay. Okay, cool. So this is where we shall be starting. Let's go down. Now these are all the topics that we're going to go through. This is not an exhaustive list at all. There is a lot of depth in a programming language. There's a lot of concepts that if you really do want to learn how to program that you will need to learn, but that's not like the focus of what we're doing today at all. We just want to kind of get some simple things out of the way, get you comfortable with the language, and then we can move on from there. So if you see that, we want to learn some basic stuff like data types, variables, like how to do mathematical operations, getting input, and things like if-else statements, which are very, very important, but we shall be learning this, and let's see how we go with time. By the end of it, we will obviously have to put these into practice, because the best way to learn how to program is to actually build things instead of just learning theory all the time. So by the end of it, we will do 2 exercises, which will be building a simple calculator and creating a madlib. And if nobody's aware of what a madlib is, we'll get to that in the end of it. Not very complicated whatsoever. All right. Let's explain what this is. This is our starter program. So if you guys are on .NET-FIDDLE, you'll see something very, very similar to this. So let's go through each thing. And you don't need to understand all of it to kind of get the gist of what's happening, but we'll go through each line anyway. So the first thing, using system, this is basically to allow you to use other people's code. So there's a lot of good code written, and you don't want to rewrite other people's stuff if it's already there. You may as well use somebody else's code, right? Especially if it works well. So that using system command essentially just gives you access to a bunch of code that you can use to do things. So very, very useful. That public class program bit, don't need to worry about that right now. And that public static void main bit, don't need to worry about that now either, but basically what that is a function where we can write our code in, and a very quick rundown of a function. A function is basically something we chuck a bunch of code in, and then we can use it a bunch of times throughout our program, instead of just writing the code manually each time. Don't need to worry about that now. All you need to know is that we want to write our code inside that main function. So between those 2 curly braces was where all our code will basically go. And you can see we already have 1 line of code. So let's actually go through what this 1 line does. So what it says is console.writeLine hello world. And what the console is essentially is an area for you to output what you do. So as you can see, we have a command there, console.writeLine, and then inside speech marks we have the words hello world. Very, very simple command. It basically just takes what's inside those speech marks and puts it in the console. So as it says there, hello world. So if we like change this, we can obviously do different stuff. Like, does anyone want to give me a string? Any random string whatsoever. Anything ridiculous. Happy birthday? Happy birthday. Okay, I definitely misheard you, but I'm sorry. I'll just put happy birthday for now, just to show that we can do this. And if anyone doesn't have dark mode, yeah, I use the dark mode thingy. That's why it's dark. I can't stand the light mode. It sucks. It hurts my eyes. So if you see right here, we'll run this. Boom, changes output, right? What happens in the terminal, sorry, not the terminal, the console. What happens in the console is dependent on what you write here. So for instance, we changed that. We wrote something else came out. Very simple example, but that's kind of how programming works. You give the computer commands and it'll do things for you. So what if we actually duplicated this? I feel like a very smart person will tell me what happens here. Or if I put like something else. Can anyone hazard a guess as to what is going to happen here? Go ahead, I'm taking this away. That's a 4. Does anyone want to guess what happens if we run this code? Like I said, there's no dumb answers. What's up?
It's going to print all of them.
It's going to print all. Absolutely correct. Absolutely correct. So, as you see there, it prints all of them. Very, very basic command right there. Console.writeLine, and you'll have the speech marks what you want to write in it, and it'll write that out. That semicolon at the end, don't worry about that too much either. It's just something, it's just a quirk of most programming language. It has a semicolon at the end, and that's kind of to tell it that this command is finished. We want to do another thing now, but don't need to worry about that too much right now. So that is a very, very, very basic C# program, but it's a start, right? That is our starter program. Now, but as we were talking about right now, output into the console, you can output a bunch of different things to the console. So we did a bunch of like happy birthday 11, some other text. That's what we outputted to the console, but we can output other things. So you can output shapes. If you put that in, it'll obviously print that out. And that's how outputting to the console works. Now before I move on to this, does anyone have any questions? Now we're going to move on to something a bit more complicated, because obviously that was a simple line of code. It's not very exciting. It doesn't do a lot of things. We're going to move on to data types and variables now. Okay. Now data types, how can I describe this? Each programming language has these things called data types. And basically what they are is they represent different things you can represent in the code. So you saw in the speech marks, right? We wrote something and it went into the console. We can represent different things in code. If you look at this, we have a bunch of stuff. We have a thing called int, integer, string, string word, float, float number, and so on and so forth. Data types essentially, like I said, are just different things you can represent in the code. So you can probably ascertain that int is indeed an integer. You can give that an integer number. String, you can give a string value. Float, double, we'll get to that in a second. Bool, try, we'll also get to that in a second. So the main concept I want you to take from this slide is data types are just ways you can represent things. Those are data types, but before we can get more in depth into what data types can do, we need to understand the concept of variables. So can anyone here actually tell me what variables in programming languages do? Anyone at all?
Storing information.
That's perfect. That's literally exactly what it does. A variable just stores some information for you, right? You don't want to, I guess, like before in our previous slide, we gave in static values, or that's not the right word, but we gave in values that we'd have to change all the time. And it's much easier and much simpler if we give things symbolic names. So that first one, if you want to store a specific number, like for instance, what does that say? 1. If you want to store this number 1, we don't want to put we don't want to put the number 1 all over the program. Like, ooh, let's put a 1 here, let's put a 1 there, let's put a 1 there. If you want to change your code, you're going to spend a lot of time changing that specific, like everywhere you've put that number. So we have these things called variables that we can use instead. Oh, zoom in a little bit, thank you.
Yeah.
All right, so we have these things called variable that will store the information for you. So integer number has a value of 1. As you can see from the syntax, it's quite simple to assign variables. You just use an equal sign and then give it the actual value. A string is basically like a sentence. You just surround it in speech marks. Then you have these other ones, float number, double number, and char letter. Okay, so variables, store information. Back to the data types. So we use these variables and these data types We use them in conjunction with each other. We use them in conjunction with each other, and we use them to do our bidding essentially. Now, just a little bit more on data types. An integer number is just an integer number. Theoretically, integers should go from negative infinity to infinity, right?
Okay.
I don't think the computer would be very happy with that. Don't think they can do that. So there is a hard limit on that, but the numbers are pretty big. They're pretty massive for integers. A string is basically just a string. Like you see, I put my name there. You can really put whatever you want as a string. It can be the name of your dog. It can be a sentence. It can be anything you want to encase in a string format. Now, the difference between floats and doubles, you can basically think of them as decimal numbers. The biggest difference between them is accuracy. As you can see, floats have about 7 or 8 bits of accuracy, whereas doubles have a lot more. In most cases, if you want to use a decimal number, you can use a float. It doesn't really matter. It's quite arbitrary at this point. So you can use either or. Now, before we go on to the last two, why I'm bringing all these data types up is because if you want to make a game, these are kind of the building blocks or the main ones that you're going to use to make your game, right? Like for instance, why are we talking about integers? What could an integer represent in a game? I would say that, like, let's say for instance, your health in a game. That's a number. If your health is like 100, you need to represent that in some way, right? Integer. Now, a string. Maybe you're playing an online game. Maybe you have your, what do they call them? Online IDs, PlayStation IDs, something like that. Maybe you have that and you need a way to show that to the screen, right? That's not a number. So how would we represent that? Using a string. That's where strings come in. Now, floats and doubles, decimal numbers, right? If you want to, okay, can someone give me a good example of where you would use a decimal number in a game? Because I'm actually blanking really hard. I can think of another example, but not
When you're using a multiplier.
In what context?
Multiplier of a score, for example.
Score, but we can represent scores in an integer way, right? We can represent them as whole numbers.
Also, or to try to represent percentage number.
Yes, absolutely, exactly, right? If you want to represent like 57.4 as a percent, like as a number, like do you have 57.4% health left or something? Sorry. You can't represent that as an integer, right? It doesn't work. It's not the correct type. So in that instance, you would use a float. Great example. Double, like I said, exact same thing. It's just it gives you more accuracy, but in most cases, you probably would not need those 15 bits of accuracy. So those are 4 pretty important data types you would use in making a game, right? Those last 2 are also important. We'll go through them. This is going to be a bit of a weird concept. Does anyone understand the concept of a Boolean? Go ahead.
True or false?
Absolutely correct. Can you expand on that a little bit? Okay, so a Boolean is, like I said, is true or false. It's a value that either is true or it's false. There's no in between. It can't be maybe, right? That'd be a bit weird. So, like for instance, that variable right there, bool is no a cringe equals true. So I've assigned that a value of true because I do believe I am cringe. But for instance, if I wasn't, I'd give that a value of false. And essentially, these are important in the context of perhaps you want something to happen if this was true, and perhaps you'd want something else to happen if this wasn't true, but you're maybe not aware of that. So a good example would be, say you're playing a game and you need to get a specific score before the time runs out, right? And let's say the target score is like 50, but time runs out and your score is 35. Something different should happen depending on whether you hit that score or you not hit that score. You don't know if you hit that score, you're playing the game. The game finishes, you hit 35. It'll show up a screen that says, oh no, you lost. That would be an instance of perhaps has player 1 being true. Sorry, that would be an instance of has player 1 being false. False or true? It depends in that context if you've won or if you haven't won. If you hit that score or if you not hit that score. If you haven't hit that score, like I said, it's going to show you a screen. You haven't won, you lost. But say you did. Say you went over 50. Then I'll show you a screen that shows, yeah, you won. Awesome, right? Great. But you can't plan for that until you reach that point, until that game has been played. And that's where Booleans come in. You can write code that basically handles that for different situations. So you can write code for this should happen if the player's won, that should happen. If the player's lost, that should happen. That's exactly where Booleans come in. You can do different things depending on something. Would be a good way. But those are Booleans. I'll think of a better way to explain that later maybe. Last one, char. You don't need to worry about this too much. It's basically, it presents a single character. So you can see from the difference between a char and a string. The string is enclosed in speech marks, while the char is enclosed in not speech marks, or like single quotes. This is a very, very like easy mistake that people make when they start programming. I did it a lot when I started programming. You basically want a string of something and you enclose it in those single quotes, and you wonder why is it not working. So there is a big difference between the two, even though it looks quite small. And a char is essentially just one character inside those two speech marks. Not speech marks, sorry, those two dash things. Yeah, that's correct. Two dash things. You don't need to worry about too much about chars. I can't even think of a good reason why I use them right now. There's obviously uses for them, but I just want you aware of them. And those are kind of the main types, the main data types inside every programming language. Right. So just so we're aware, and if you look at the code here, we have console.writeLine. So we're going to put so we have this code here. The integer is, the string is, the float is. That's a string, and we want to print out one of these. So let's actually do that this example and see what happens. Let's take that. I'll do the whole thing actually. So console.writeLine, and as before, let's use an integer. The number is, let's enclose that for now. So we have a string that'll print that, but won't actually print our number. What am I doing? There we go. Let's actually initialize a number. Int some random number. For future reference, naming variables is really annoying because you don't know what to do. So I usually end up using like a and temp1 and temp2, and they have no relation to each other, and it's weird and it's bad. So let's say we have an integer number or some random number 5. We've given it a value 5. This, as you can see, int, that's the type, some random number, that's the variable name. Every variable has to have a variable name. You can't repeat them, so you can't have like, I couldn't do this, but, and then have the exact same thing. It would, well, you actually, yeah, this would be an error because we already have something of this name anyway, so that would be pretty bad.
Can you have numbers in the variable name?
Excellent question. And if I actually did that, wait, I'm 95% sure you can. Let me just test it quickly. There are what do you call rules around naming variables. Absolutely. Like for instance, I'm pretty sure most languages wouldn't let you start with like a number as the variable name. That'd be pretty odd. Random 5 number. And if I run this, compilation error. System console does not contain definition for writeLine. System console does not create a definition for writeLine. Why does it not create a definition? Oh, because I don't. There's another very important thing. Small l as opposed to big L. Things need to be written correctly or else they don't work. Right, awesome. So yes, you are correct. We can put numbers inside variable names. Each language has its own kind of rules around how you can name variables. But honestly, like as long as you don't do something crazy like what's a really odd string? There you go. As long as you don't do something like that, like most variable names will be fine. And anyway, the whole point of variable names is to give it a name that you can use throughout your code, because code is meant for humans to read. If we did weird names that other people can't read, they won't be able to understand your code. They won't know what the hell you're talking about. If you have to go back to our other example, if we had a variable for our health, and instead of calling it health, we called it like by6r. That is a completely random name. People will have no idea what the hell you're talking about. The programmer that comes after you will be super pissed off at you for one reason. So that's the whole point of variable names. Just you make them descriptive, so when you look throughout your program, you can be like, oh, that's not a number I'm looking at, that's a variable name. It represents a number, but I'm not thinking of it in that way. I'm thinking of it in a way that I can actually read and understand myself. So let's actually change that back.
Could you not update the variable name?
Could you not update the variable name?
Yeah, like change the value of it.
You 100% can. Absolutely. You do need to be a little bit careful about how you do it. You know, I'm going to call this num. I'm being lazy. I can't be asked doing a long name. Okay, you could. But like that previous example where we went int num equals 7. What the hell did I do? Nothing. Great. Okay. This doesn't work because num if we run that, see, this doesn't work because we've already defined a variable named num. We already have something called num. We can't tell it, oh, here's another num. We already have one. It's like there's like one of you, and like I want another version of you. It's like there's already one of you. That's would be a little bit odd, right? Okay, but what we can do is we can give variables new values. You just don't declare them. See, it's already there. That whole purpose of that int is basically tell it we have a new variable. It's an integer. Here's its value. We want to give it a new value. Let's just use the name. That's what we have to do. So you can see we got a value of 5 here. We got a value of 7 here. We're going to print this out. It's 7. So that was a good point to bring up. Thank you very much. And that's how, what was I even talking about? Yeah, that's how data types and variables work in C#, although it's pretty similar for most programming languages, except Python, because Python's weird. Okay, any questions related to data types or variables? Oh, sorry, there you go.
So, in the printing line,
Yes.
we added integer to a string, right?
Yes.
What's the variable type it would be after we added the integer to a string?
Yeah, that's a good. That's not a good point. So as you can see here, that's a string, that's an integer, and we're adding them together, right? I haven't heard of an integer and a number being added together in normal math. Never heard of that. Maybe I have. I'm not good at math. So this whole value is going to evaluate to a string, and that's because this console.writeLine. This is like a bit more than what we need to know, but basically, this method takes a string, and I know that probably doesn't mean a lot to you, but that's the explanation for it. We'll get to methods a little bit later, but yeah, whatever's in here, no matter like what you do, it's gonna be a string. A weird thing, if I did like num plus num in there, and I gave it, no, that would still work because it converts the number to a string. So your question is answered? No. Wait, sorry, what was the question?
Yeah, what's the variable type like after we added that?
It'll be a string. It'll 100% be a string. That console.writeLine returns a string. 100%. So that's how that works. Yeah, I'll get back to methods a little bit later. They're very important, but we'll get to that a little bit later. Any other questions related to data types or variables? I see no raised hands. I shall soldier on. Okay. Next thing, this should be pretty easy, I think, for you guys, considering what we just did right now. Next thing we are going to talk about is mathematical operators, and this is, as you would guess, just different ways to manipulate mathematical data types. So integers, doubles, floats. There's a lot more than that, but those are the ones that we shall talk about. So you can see here, right, we have an integer, and we're performing a bunch of math on it. So a lot of these you can probably just ascertain just by looking at it. 5 plus 6. If you want to add two numbers together, you use the plus sign. You want to minus a number, use the minus. Timesing a number is that asterisk. Dividing a number is that, what do you call that? A forward slash? Yeah, forward slash to divide numbers. And that little thing over there is not common, it's not used everywhere, but does anybody know what that is? That one right here, does anybody know what that is? Yeah, there you go, exactly. Wait, who said that? Thank you. That's the modulus operator, and essentially that just returns the remainder of a division. So if I had like 5 divided by 2, that would return 1, because 5 divided by 2 is 2 well, it's 2, then remainder 1, something like that. Yeah, it's 2 remainder 1. So modulus operator just returns the remainder of a division. Kind of important, but I just want people to know about it because it can be very useful in certain situations. Right, can anyone actually give me the answer of that first chunk of code, all the way from integer number down to right line integer number? Yes, it is 0, absolutely, it is 0, right? So 5 plus 6 is 11, minus 3 is 8, times 2 is 16, divided by 4 is 4, modulo 2 is 0, because 4 divided by 2 goes perfectly into each other, and there is nothing remaining. So that is absolutely correct. And that's how we would use some of the mathematical operators if we wanted to play around with numbers in C#. Now, we have another thingy-mabob. This is for, sorry, what is the word? Not for integers. This is for decimal numbers, doubles. I use doubles. You could use floats. It's not a big deal. So I just use doubles in this case. And I'm doing the exact same operations, except doubles can be a little bit different. So programming languages can be very weird in how you do math sometimes. You would get some very unexpected results. I'm going to show one of those right now. You might be a bit surprised. So we have our integer number 5. Okay, And let's do another number. Let's do int. See, this is where like my coding conventions get shit. Int num1, great, right? And let's say that's 2. This isn't probably the best, but let's make another number, and it'll be the result of those, or the division of those. Int num2 equals num1 divided by num divided by num1. And this is where variables come really in handy, right? I didn't have to put the actual values in. I just had to put their variable names in. So I can change. So like for instance, if I wanted to actually change their names of these, I could just change it up here, their values, and it'll reflect down to over here anyway. So let's actually, the number is plus num2. Let's print this out to the console. Can anyone, oh, why is that there? That should not be there. Can anyone tell me what the value of this would be? Just anyone. Does anybody know? What do you think it is? 5 divided by 2. I forgot the semicolon. 100%. And why is it 2?
Because you chose an integer, not a float.
Yes, absolutely correct. 100%, right? It's weird though, right? 5 divided by 2. That's clearly 2.5, right? It's not 2. But that's what I'm talking about sometimes. Mathematical operations, depending on what you're using, can be very weird and tricky and not fun. And you'll be wondering, why is that the result? But you won't know. So that's why I have this whole chunk of just dedicated to a double, just because they play around a little bit differently. So for instance, God, do I actually want to do this? Okay, 4.2. Actually, no, you guys have calculators. I don't have a calculator up here. Does anybody want to hazard a guess as to what this is? This double chunk right here. I'm try doing this in my head. I have to be like 8.6. No, I gave up at the multiplication part. I can't do that. But yeah. Wait, actually, I'll just put that all in. What am I messing around for? I have a programming language in front of me that'll do it all for me. Let's call this a double. So we've got 4.2 plus 4.4. 4.2 plus 4. Okay, minus 3.5. And if anyone wondering, yeah, BidMath, like the order of operations that you usually have in math, does apply here. So if you don't want your multiplication happening before your whatever's, surround them in brackets, which is exactly what I should be doing. Let's go with that. Okay, 4.2 plus 4.4 minus 3.5. Yep. Let's just surround all of that so I don't get anything wrong. I'm a bit paranoid. It might still be the same thing, but I just want to make sure. Times that by 2.5. Divided by divided by 4.0 and then modulo by 2. We'll forget about the modulo for now. It's fine. Divided by 4.0. Okay, so I have 1, 2, 3, 4, 5. Shit. Yeah, I've definitely messed up. 1, 2, 3, 4, 5, 6, 7. This is where when you get too many brackets, you just get super confused about what's what. So these two are fine. This one and that one should be fine. Then that one and that one should be fine. But then this one and this one should belong here. So if I have 1, 2, 3, 4, 1, 2, 3, 4, yeah, that should do it. Okay. Does anyone have a guess? Does anyone know what the actual answer is for this? I definitely don't. Yo, 3.1875. Awesome. So
Percentile 2.
wait, sorry, what was that? Percent 2? Oh no, I just discounted that, but yeah, you could do that. Without that, that would be the answer. I know that was a bit of a long-winded thing. No, I just wanted to basically just say mathematical operations can be tricky depending on what data types you use. As you can see, they're different for integers. They're different for doubles. You can even do mathematical operations on strings. Would you believe that? Honestly, would you believe that? If I went, this number is, I hope this works actually. I haven't used C# in a while. No, that definitely doesn't work. Not in this language. But you can even use mathematical operations on strings. Like for instance, in some languages, I forgot how to do it in C#. If you times a string by 2, right? What would you expect that to be? Yeah, it would literally be a string. just once in the start, then once at the beginning, right? Just one right after the other. And you wouldn't think that because it's a mathematical operation, but that's, math can work in weird ways depending on what data type you use. That is mathematical operators. Ooh, what's this? Yeah, that's right here. That's just a whole point about being careful in what order you put things. Obviously, BidMath applies here. You don't want to put something like in the wrong order and then it gives you a different result because you had a times there and you had a minus there, and then like I did that first, but you didn't want it to. So keep that in mind. That was mathematical operators. Phew, that took us a while. How are we doing for time? Dot operators and methods. Okay. Okay. Now we're finally going to get on to this part, which I said was important before. Okay. Dot operator and methods. So I'm sure it hasn't escaped your attention. We have a little dot there. That's very, 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 very important. Can anyone tell me why that's important? There's a dot right here. So you see how console dot right line. Why does it have a dot there?
Square root method belongs to the math class.
Exactly. And wait, what does that mean?
So like math, somebody else made a program that worked out square root. It has a math class, and within it square root is that, so it belongs to someone else.
And that's where methods come in, right? Like I said earlier, we're using system. We're using we're using code that other people's written because we don't want to write all those millions of lines of code, right? That's would be a bit time consuming, correct? So this whole dot operator gives you access to other people's code. As you can see, we haven't written anything for square root. Like there's nothing referencing a square root in our program. Yet we can use that dot operator and it'll give us access. We can give it a number and it'll give us a square root of that number. So the whole point about the dot operator is it just gives you access to code that may or may not have been written by another person. You can obviously write the code yourself if you want, but kind of just a gateway into that. That's what the dot operator does. And right next to it, methods. Methods, before I said a function was basically a chunk of code, right? Like right here, public static void main. And then inside that we have all our code, and all our code runs. A function is a chunk of code. And a method is kind of the same. So for instance, that square root method. Square root is a method. So somebody's kind of written this. They would have given it a name square root, and then they would have written all the code that allows you to like get the square root of a number. We use methods because we don't want to use all that code all throughout our program again, right? It kind of goes back to variables. You give something a variable name, and then you use it throughout your program. If you change the variable name, it'll change throughout your program too. A method's kind of the same thing, right? You write a bunch of code, and then you can use that method wherever you want. So you can see a few examples right here. Console has a method called writeLine, which will obviously write some string to the console. Square root has math has a method called square root, which will give us the square root of a number. String name has a method called length, which will give us the length of our string. And math.floor is another one, will just give us the floor of our number. So if it was like 3.3, it'll just give us 3. So the whole point that I want to point out here is methods. Very important. You want to write your codes and methods, you want to use them all over your program. And they're very, very, very useful. So those are methods. Okay. Now we're moving on to something a little bit important, but not really in the sense of coding. I know we've gone through a lot of stuff. Don't worry, you'll get a break soon and we can actually put these things into practice. Comments. I want to make a very, very quick point on this. Comments are literally just a way for you to communicate with your fellow coders, right? You don't want to be that guy that has no comments. You quit your job, somebody else gets hired, they come along and they can't read your code for shit because it's just a bunch of code. They're not a computer, they're a human. They need human languages to read. So as you can see here, a comment will describe whatever you've written, essentially, right? So you can see here we have a few variables that we declared. Those are things we've done. We've declared a variable, we've declared an integer, we've declared a string, we've declared a double. But right above that commented line, basically that does nothing. That's just for you to write to help somebody in the future, or to help yourself when you like go away from your code for a few months, then you come back and you don't know what's happening. That's basically what a comment does. And there's a few different ways of commenting. If you want to do like a multi-line comment, you can write like a whole essay here if you really feel like it. Yeah, Last of Us 2 is amazing. Okay, that's basically what a comment does. Like, and also like if you like have a bunch of code but you don't want to delete it, you can just comment it out and then uncomment it when you want to use it again. Very, very useful. Okay, what else do we have left? Okay, 2 more things. Getting input, right? So this whole time we've been doing our own thing. We've been writing our own variables, we've been giving our own values. We've kind of been acting under the pretense it's just us and there's nobody else. But what if there is another person? What if you do need to account for somebody, e.g. a player? So I'm pretty sure everyone's played games, right, where you put like your own input in. Going back to that example I did before, if you make an account online for something, like a league account or whatever, I never played league, sorry. You need to you need to like put a username in, you need to put a password, all that jazz, right? That's what's called getting user input. And now right here, if we can see, we declared we declared an integer, age, and a string name. Another quick point: if you're declaring variables, you don't need to give them a value. It's very weird to not give them a value, because if you use them and they don't have a value, odd things can happen. But you don't need to actually give them a value. And this is a pretty good example of where you shouldn't give them where you don't need to give them a value, because it's already going to be given a value once you get input from something. So we go down here, console.writeLine. What is your age and name? Yeah, I don't know why I did it that way around. It's a bit weird. So console.writeLine. It'll write what is your age and name. Now we're going to give age a value of this line right here, this code line. int32.pass console.readLine. Now we know what console.writeLine does, right? It just prints something to the console. What does console.readLine do then?
It's you input string.
Yes, it does. So console.readLine, the program will wait for you. It'll wait for you to put something in, and it'll take that. It won't continue on without being given something if you do use that command, console.readLine, or that method. They're all interchangeable. Now, we have an int age, and the console will take an input, but it'll take it as a string. Kind of shit, right? We don't want to just have strings. So that's where things like these come in. That's another method, int32.pass. Just ignore the 32. int32.pass will take that string and will turn it into an integer. That's how you can get input. That's how you can put input into the console. It'll take that. It'll convert that to something that you actually want to use. You don't know that yet, right? Because you haven't started the program. You haven't put any input in. But once you do, that's what it'll do. It'll take that input and it'll put it into age. Same thing with name, but in this instance, since it's already a string, we don't need to do any fancy stuff. That top bit, int32.pass, we need to do that because it's a string, right? And we want to make it into an integer. There's different ways for different types, different ways to pass things, but right now we're just doing those two. And then, right, if we do console.writeLine, my name is plus my name, I am, age, yada yada yada, it'll print out whatever we've written. So I will do a very quick example. Let's take all this mumbo jumbo away. Let's go int age, string age. Yep, I am not the best typer in the world. So age doesn't have a value yet. If you really want, you can give it 0 or like an empty string. Like honestly, that'd probably be the correct thing to do, just in case. You don't need to, but you can. Now we're gonna give this a new value, and like we said, int32.pass, and it autocorrects for me. It's so nice. Console. Quick point. I know I've kind of strung things together, so we've put that command inside this command. If it makes you feel more comfortable, you can make another string, and you can just put console.readline inside that. If it's too many things happening at once, so we don't need to do all that together. We can, I guess, have a temporary string. String temp equals, and then we can do console.readline in there. This is going off the slides now. If this doesn't work, I blame you guys. Okay, string temp equals console.readline. That'll just give us our input, and I'll put into that. It'll be a string. So instead of doing all that jazz over here, what we can just do instead is give it temp. Since we know temp is a string, we'll just chuck it in there. It'll pass it for us, and it'll give us back an integer. That'll be for the first one. Then for the second one, we can just do name equals console dot readline, and this time, since we want to string back anyway, we don't really need to bother with anything. I guess I'll just be that way. So now we've been given 2 inputs, and we've given them 2 variables, and now we shall output them to our console dot write line, and it will be, I need to be careful, I need to actually put this in speech mark. My name, no, sorry, my age, because I did age first. That's another thing. I did age first, so if we put the age in first, and then, like for instance, it says age, so it's wait, I forgot this thing right here. Let me quickly write that out. I forgot that. Let's put that right here. Console. This is just printed out for anyone so they can actually see what we want. Console dot write line. Sorry. Cool. And what did it actually say? It said what is your age and name? You know what? I'll change that. No, I won't, because there'll be more changing around. What is your age and name? Cool. That'll just print that out. And this way, people will know what we actually want. They want an age and they want a name. I'll make a quick point that if they put like their name in first, it'll go here, and then I'll go here, and then I'll throw up a big ass error. And I'll show that in a second why. But first, let's do my age is. Let's actually add the age. And my name is Bob. Let's add the name. And did I forget anything from this? No, because I'm being a douchebag. That's why. Yeah, sorry. Doesn't matter what way I do this one. My name is name, and my age is age. Sorry, that was didn't really need to do that. Okay, finally. Now, if I run this, compilation error. We're on line 14. Yep, I forgot the semicolon. Very important. A local variable age already done. Ooh, wait, what's that? Okay, so errors. Line 8, it says, yeah, because I called this age where I should have called this name. That was really weird on my part. Cool. Okay, if I run this now. Cool, okay. Finally, thank God. So you can see, we run this program. What is your age and name? It's asking us. Oh, we're so special. Let's put in an age. Let's say, well, I'm 21. And let's put it in my name. That's my name. And I'll print that out. Super simple, I know. But that is an example of a program taking an input and then doing things. And this can be very like, this is a small example, right? But imagine, maybe not really a game example, but imagine you have a bunch of data you want to process, right? And you want to do something with that data. That is like the fundamental concept of taking input in. You take all that data in, you do something with it, and then you spit it back out, or you know, in whatever way you want. That's why taking an input is super duper important. Maybe too many dupers, but it's like it's important. It's important, and that's how that would work. And you got to be careful with these sometimes, just because. Let's say I run this, and let's say I put my name in first. So bop. Oh no, it doesn't work. Why doesn't it work? Very simple, because it would have written this line, console.writeLine. It would have gone down here, string temp. It would have read our name, sorry. Then it would have gone right down here, and it would have tried to turn it into an integer. You need to be careful sometimes with the flow of your programs, or elsewise things like this happen. So obviously you can't turn a string into an integer, a bit ridiculous. But yeah, that is the concept of getting input. We're almost there. Last bit of, is it the last? Yeah, it is. Last bit of stuff I want you to know, and then we're done. How's everyone doing? Yep, cool, awesome. Awesome, okay. Last thing, if and else statements. And this is where we come back to booleans, and I said how they're important, right? This is a fantastic way you would use booleans. So, you see this code right here, right? Bool, is Noah cool? True. Now, if Noah is cool, do this thing. Else, do that thing. And I think this is pretty intuitive. It's basically, like I said before, two different actions based off that boolean. And the syntax for it, as you can see, it says if, and then I just put in is Noah cool. So inside those brackets, if that evaluates to true, it'll do that code right there. But let's say, for instance, that is Noah cool has a value of false. I'll go down to that else statement instead, because obviously that first if has evaluated to false. It's saying, no, this is not correct. I don't want you to do this code. And then I'll move right down and I'll do that other bit of code. That is the whole bit of a if statement. And there is a little bit more on if statements. You can do else if, which is kind of like an extension on it if you want to have like multiple cases. But let's do a quick example of an if statement. So let's take all this away. Yay. Okay. Let's have an integer, required score. And let's say the required score has to be at least 70. This is actually a good way to do our input as well now. And now let's say int user score equals, let's go int 32 dot parse. Am I making this too complicated? Do you guys think I'm making this too complicated? Yeah, fuck it. If it's too complicated, it's too complicated. Okay, let's go int 32 parse, and we'll do console dot read line and that. Okay, so required score is the score we want. User score is the score we actually have. We're gonna supply it ourselves. We're gonna assume that we're honest. Okay, and then what we would do instead is let's actually have like a console prompt, console dot write line, where we can tell it, oh glorious player, what is your score? Asking for our score. Console dot, wait, why did I write? Yeah, that's awesome. So that'll write, you know, that prompt right there asking us for our score. We'll actually put in our score and I'll give it to user score. This is where if statements and booleans come in. If now the required score is 70, but let's say it's less than 70. If, let's go user score, yeah, that little symbol right there, that little sign right there is just a less than sign, you know, just like a normal math. If user score is less than 70, we can go, yeah, curly braces. We can go wait, actually, you know what, let's go a little bit back. Quick point on these curly braces, because I know they pop up everywhere in the program. They are basically used to kind of limit the code, right? So we have this whole if statement. Let's go a little bit back. This basically just tells it to do everything inside these little blocks. So make things a bit nicer, a bit neater, a bit easier to look at. So we do, those curly braces are actually important. If you don't have them, then you do get errors. Curly braces. Okay, so let's get back to it. If user score is less than 70, let's say we print out console dot write line. But I wish somebody else was coding. I'm very slow. Okay, hooray! Hooray! You won. Wait, it's less than 70. Hooray! You lost. Okay, there you go. That's if it's less than 70. Else, oh, I keep doing the bloody thing. There you go. Else, cool. Okay, else. Now in this instance, we have our user score. If it's less than 70, right there. If it's less than 70, it's gonna print that line. For every other instance where it's not, if that number is not less than 70, if it's 70, 75, 105, whatever, if it's not, it's going to do that else statement instead. It's going to do everything inside that else and those else curly braces. That's the whole structure of an if else statement. You do this thing based on that thing. And I know how and maybe we're going a little bit too far, but you can see this is a boolean and it says true, and we put that in. Certain statements have different values. Like for instance, 5 plus 5 has an integer value, right? User score less than 70. That doesn't give you a value back. It does give you a value, but it doesn't give you a number back. It gives you, like we said, true or false. Either user score is less than 70 or either it's not. It's going to give you either true, either false. It doesn't give you a number. And that's what I mean by putting a boolean inside these if else statements, just to kind of see what we want to do. So this user less than 70 is the exact same as like this boolean having a value of true or false, whatever. It's the same thing. It's just written a bit differently, is all. Like for instance, if you really wanted to, we could do bool is smaller equals user score less than 70. If we really wanted to, we could just do that. We could take this stuff out and we could put in this boolean instead. Makes you feel better? We can do that. else I'm going to copy paste now, one of the hallmarks of programming. Tab, copy paste, hooray, you won, hooray. Now if you run this program, it's going to have errors, definitely, yeah it does. Okay, line 24. So apparently I've missed out some, yeah, 100% I just need to figure out where exactly I'm missing it. Is it right here? Line 17, the name Ismail does not exist in the current context. Yeah, I spelt it, did I spell it wrong? Yeah. That's why you gotta be careful, because I spelt it wrong, and that should run. Oh, what was that? Okay, sorry. So yeah, okay, so there you go. We run our program. That's the required score. It's written to our console. Oh, glorious player, what is your score? Now, let's put a score in. I'm gonna say our score is very terrible because we're trash players. 12. Hooray, you lost. As you can see, I got our user score, which was 12. 12 is indeed less than 70, so this would have had a value of true. That's true. True statement. We chuck that in here. Is smaller is true, so it'll do this. And it won't do this one because it's dependent on what value you give it. If this happens, this does not happen. If this happens, that means that did not happen. That's kind of how it works. So if we run that again, let's say we did really, really amazing. In fact, our score was 120. We won. We won, and that's because we got the score. User score was 120. 120 less than 70. That's clearly false. Mathematically, that doesn't work, right? So we're going to come here. This right here is smaller, will have a value of false. It'll look at that. It's false. Okay, we're not going to do this stuff. This is false. We can't come inside here anymore. We're locked out. It'll jump down here to this else. Boom. Hooray, you won. Now, that's the very, very basic setup of an if statement. If you look at the slides, you'll see we have else if as well. That's also similar, except if you want more cases. So I'll do like one more case. Else if, let's say we don't want, let's say just because it's smaller than 70, we don't want it to go straight here. Let's say we want to look for something else. Else if, let's say user score is equal to, that's an equal sign, just seeing if user score is equal to whatever's on the other side. Let's say like 34. Let's say if it's equal to 34, we're going to do something else, which is going to be, where's my, oh, that was a tab button. There you go. God, these are so terrible. Hooray. Hooray, it's 34. Yeah, because that makes sense. Cool. Okay. We just added one thing, just another case. So in case it's not smaller than 70, okay, let's say it's not smaller than 70. Wait, let's do sorry. That was actually that was a thing on my part. If it was, this wouldn't happen. If it was 34, this wouldn't happen at all because 34 is smaller than 70. This would have been true and it would have gone down here and it would have never reached this part ever. Because out of these, it'll only execute one of them. So let's actually make it 75. That works better in R1 because, as you'll see. Okay, cool. Let's say it is indeed, let's say it's 45. Okay, we lost. It went right there because it's less than 45. Let's run it again. Let's say this time it's in 75. You can see it's 75. That is indeed, like, that's greater than 70, right? And it's equal to this. So it won't do this. It'll come down here. It'll look at this. Oh, that's equal to 75. Let's do this. Let's do this line of code, and then it'll ignore this one. So my whole point is, if else statements, else ifs as well, it'll execute one of them, and then the rest are left alone. It just depends on how much different stuff you want to look for, really. And I've had bad stories of having like lots of indented if else's. It's like if else's inside of if else's inside of if else's, and it's it can get messy sometimes. And that is, I think, everything we're gonna do today. Can't get out of your seat yet. I want you guys to put this one in practice because it's all well and good me telling you this is how it works. That's what you should be doing, but this is like one of the things about programming. You need to do it to get better. That's the only way you get better. You need to keep doing it. Theory is all well and good, but you need to keep programming in order to get better. First thing, I want everyone here to build a calculator. It has to be capable of addition, subtraction, multiplication, and division of two numbers. So the specifications would be taking two numbers, take an input for, I guess, what we want to do with those numbers, and then do it. Here's a hint, double dot pass might be quite useful in this. You have 3 minutes. Okay, you have as much time as you want. let's take a quick break. And if you have any problems or anything, just scream at my face, and I'll come over and try to help. No, you guys have so much energy? Awesome. Okay, we'll go for another 2 hours. Okay, that was how to make a simple calculator, and I'm sure you guys had problems with it, right? Coding even small things, simple things, can be really difficult. there's bugs everywhere. We're not computers, like we never will be. So bugs and problems are bound to arise, and if that happens, just keep banging your head against the laptop until it works. Well, that's what I do. Okay, that was one of our exercises. You don't, since it's 7:30, you don't need to do this one. You can if you want. You can do it here. You can do it in your own time, whenever you want. And does anyone here know what a Mad Lib is? A Mad Lib. We did this in my Comp Sci 101 class. It's basically like a series of sentences. You take maybe one word out of those sentences, and then you ask somebody for input. They'll give you a bunch of words, and you'll put it back into those sentences. But the fun of it comes from the person inputting the words. They don't know what the sentences are. So you get some weird input, you get some wacky sentences, and you get some pretty hilarious essays, not essays, paragraphs. I don't know why that was so hard. You get some pretty hilarious paragraphs. So that's basically what a Mad Lib is. You get a bunch of words, fill in the blanks to a bunch of sentences, and you can do this if you want. You don't need to, like I said.
You want to do examples?
Oh, right, yeah. Thank you for it.
That's why I'm standing here.
Yeah, that's why you're here. Okay, I'll do a quick example. So, let's say I want to get 3 strings, and this is another way to declare stuff as well. Right now, I'm gonna call it S1 and S2. You can just do a comma if you want to like declare multiple ones of the same type. You can just like go with that. Nice trick. Except don't call them all S1 because that's not smart. S3. Right, let's say we want to get 3 words, and we'll do the exact same thing. So S1 equals console dot write line, not write line, read line. I'm losing my shit. Read line. Boom. Okay, we'll get input for all 3 of those. I'll make it very quick. Cool. Okay. Let's say we give it 3 words, and we want to console dot write line. Let's say we want to write down roses are. Oh, I'm already doing the whole thing for you guys.
Alright, just like a test case.
Basically, right? You get a bunch of words. You have a bunch of sentences, and then you append those words to those sentences. They don't have to be at the end as well. You can have like you can have this. You can like add the S1, I guess, and then extra bullshit. There we go. That is a sentence that I made. You can make multiple ones of those, taking whatever input you want. Just I guess make them funny. That's the whole point. And you can do that if you want. That is 7:33. I'm sure everyone's feeling pretty tired. Like I'm pretty tired. So you can do this whenever you want. I just have a few more things to say, and then I'll release everyone. Okay, first thing, if anyone is interested in joining the council, we still have a bunch of positions open. The help would be more than welcome. Yeah, so just contact us on Discord or any other one of our social medias if you have interest in like having a leadership role. Join the council. This is something I forgot to mention last week, which I 100% should have. That's my bad. This is kind of the general outline of the rest of the semester. We have launch night, which was last week. Sorry about that. Tutorials this week. Next week is a very important week, and this is when we start our game jam. And I'm sure if you guys aren't aware, game jam is you get with other people and you make a game over a certain amount of time. Yeah. Yeah. So I know you guys have just learned a bit of coding. Maybe you're not too confident on making a game with other people. The game jam is pretty long. It's literally from week 4 and it ends in week 9. So even if you don't know now, you have a lot of time to learn and attempt it. And it can be stressful, but honestly, I would just say just have fun. Just learn as much as you can. Try making a game. There's like a million tutorials online, especially in Unity. You know. So and yeah, if you do want to participate in that, you do have to be a member. That's $5 this semester to join. Yeah. If you want to do that, come along next week and we will make groups, prompts, and we'll start. Then after that, we just have a few other stuff like more tutorials, some chill night because, man, I have tests in week 6. Then more tutorials after the break. Showcase night is when the jam ends and we actually show off our games. Mystery event, which is actually in the works now, but we won't talk about it yet. Chill night for week 11, and then obviously week 12, people have exams. we kind of shut down for then. That's the general layout of the rest of our semester. But yeah, game jam start next week. Clint, am I missing anything? I feel like I'm always forgetting something.
Let's see.
Think now. I don't think so. Right, well, thank you everyone for attending. I know it was super long. I know it was a super long tutorial. I know programming is hard, believe me. It was very hard for me when I started too. Still is. Just, well, thank you for coming, and I wish you everyone the best. Yeah, round of applause for me, right? Okay,
I just have one more question.
yeah.
Do we have like recordings of tutorials on?
Yes, 100% we do. I forgot the resources page. Fuck. Wait, one thing before we go. How did I skip the resources page? Did I not put it here? Yeah,
You mean
I had a resources page that I just linked, but I obviously forgot to put it there. Yeah, this recording will be up. I had a page where I had some resources on learning C# because there's so many good tutorials online. Guys, there's so many good tutorials. There are so many better teachers than me. All you have to do is type in C# tutorial on YouTube. It will be there. Whatever you want will be there. If I go right now, alright, let's go. C# tutorial.
Oh, actually, W3 school is pretty good.
Boom. Yeah, well, W3 Studios is good. There's some
Is that? No, that's C. Well,
C. Why would it bring me C?
you might want to. Yeah, I think you made a typo of a typo in your search bar.
Yeah, I did make a typo. Sorry about that. See, I could literally go there. C# tutorial. This is the one I kind of based the content off of today on. You can see it's at 1 hour 15. But this is like, this covers basically the entire language, or like all the foundational level stuff of it. If you want to learn, there's so much stuff online. Okay, there's so much stuff. But calming everyone.